So the projectile motion is actually a two-dimensional motion in which the object is having two components of the velocity, the horizontal velocity as well as the vertical velocity. If horizontal velocity we say Vh, the vertical velocity we can say Vv, or because the initial velocity is denoted by u, so the initial velocity will have the two components, the horizontal and the vertical. If we know the angle with the horizontal, so then the horizontal component will be equals to u cosine theta. And the vertical component, the component which is opposite to the angle, that is equal to u sine theta. So what actually happened in a projectile motion, as our assumption is that when this object is moving, the air resistance is negligible. So if the air resistance is negligible, it means no air resistance. It means the horizontal component does not change at all. So throughout the motion, the horizontal component will remain same. But what about the vertical component? The vertical component, it's moving against the gravity, so the vertical component will change as the projectile is launched vertically upward. So, or this projectile is having a vertical component, so that vertical component will decelerate or slow down, and at the maximum height, the vertical component will be zero. But when it is coming down, the vertical component increases. But what is the difference between when it is going up and coming down? The sign of the vertical component will be different. If upward direction we consider as positive, the downward direction we consider as negative. And throughout the motion, the value of the acceleration, if we are considering the full motion, then the value of the acceleration will take as negative g. Why? Because the acceleration is always directed downwards. So if you want to sketch a graph for the horizontal and the vertical motion of this projectile, so for the horizontal velocity, as the horizontal velocity does not change throughout the motion. So if we have the horizontal velocity and time, the horizontal velocity, which is u cosine theta, does not change throughout the motion. So if it does not change throughout the motion, what we'll have a horizontal line, as it does not change. But what about the vertical component? The vertical component, example, we say VV, the vertical velocity, which is also equals to u cosine theta in the beginning, the u sine theta in the beginning. So it is maximum in the beginning when we launch this projectile and then start to decrease. And it has a constant deceleration. So whenever we have a constant deceleration, it should be a straight line. So the value, it will start with a maximum value. Then when it reaches the maximum height, it will be zero. And when it is coming down, it will become negative. So we will have a straight line. So for vertical velocity, what will happen? It is maximum in the beginning. So vertical velocity, it's maximum at the beginning, but it decreases when it is moving towards the maximum height. And when again it is coming down, it will increase. But velocity is a vector quantity. So if upward direction you consider as a positive, the downward direction will consider as negative. And there is no air resistance in a projectile. We assume there is no air resistance acting. How to work out the magnitude of the velocity? A magnitude of the velocity or the speed at any point, if you want to work out. So if you want to sketch a speed and time graph for this motion, speed is a scalar quantity, so I don't have to use the positive and the negative axis. I can use only one. So speed is there and time. So how to work out the speed? Because we have the horizontal and the vertical components. So if horizontal component, I say like VH, and the vertical component, I say VV. So it is making a right angle triangle, the horizontal and the vertical. It will make a right angle triangle and the resultant will be equals to the V. So we'll use a Pythagoras theorem that V is equals to under root the horizontal velocity square plus the vertical velocity square. So what happened to the speed? Because at the beginning, both are maximum. So it will start with a maximum speed. But then what happened? The vertical component is decreasing. If the vertical component is decreasing, the magnitude of the speed will also decrease. When it reached the maximum height, the moment it reached the maximum height, so what will happen to the vertical velocity? The vertical velocity is zero. So means this factor will be zero. So if this factor is zero, so it will like zero is added. So when we simplify, in that case, the speed is only equals to the horizontal speed. So when it reach the maximum height, the speed will be equals to the horizontal speed. And again, when it is coming down, the vertical velocity start to increase. So as the vertical velocity start to increase, when it reach the same location, same level, then the speed will be maximum again. Because speed is we're using a Pythagoras theorem, we work out the magnitude of the speed. So this will be the speed time graph for a projectile, but this is the horizontal velocity and the vertical velocity graph. Is it clear? Any doubt in this? Any question or a doubt till this point? The first part of a speed time graph, we have the horizontal velocity and we have the vertical velocity. We want to find the speed here. So how to work out the speed? The magnitude only we need. So if we need the magnitude of the speed, we use a Pythagoras theorem, that is Vh square plus Vy square. So when we add, we get the magnitude of the speed. That's the magnitude of the speed at the beginning. But then as the projectile is going up, what happened to the vertical velocity? The vertical velocity is decreasing. At the beginning, the vertical velocity is maximum, but the vertical velocity is decreasing. So at this point, what will be the value of a speed? The value of the speed will be the horizontal velocity square plus zero square. Why zero square? Because the vertical velocity is zero at the maximum height. So we can say at the maximum height, the speed is actually equals to the horizontal speed velocity only. That's why the magnitude is decreasing. And again, when it is coming down, the value of the vertical velocity is increasing. So as the value of the vertical velocity increase, speed is under root the horizontal velocity square plus the vertical velocity. So if the vertical velocity is increasing, what will happen to the velocity? The velocity will also, or the speed will also increase. That's why the graph, the speed time graph for all the projectiles without air resistance, it will be identical. Is it clear about the projectile motion? Now we have some questions related to the projectile. The first question, in 15th century, an explanation of a projectile went as follows. When you throw an object, you give it a force which is called impetus. It moves in a straight line until the impetus is used up. Then the objects fall vertically to the ground. The diagram shows the path described. So this is a 15th century explanation of the projectile. Correct the diagram to show the path followed by a projectile according to modern observation. So what should be the path we should draw for this projectile? The trajectory or the path? You can annotate on the screen. This is a 15th century explanation of the projectile. So this will be the trajectory or the path we should show. So a parabolic path. It can be a half motion as well, but we have to complete the motion. So if you draw till here, that is also fine. If you draw the complete, that's also fine. Now, explain why the projectile follows the path you have drawn. Your answer should include reference to horizontal velocity. Like we drew a path of a projectile We drew a path of a projectile like this. But why we do like this? Like why the projectile has a for this path? So you have to explain. Yeah, that's right. First thing, there is no air resistance. First thing, because we ignore there is no air resistance. So what will happen? The horizontal velocity does not change. So we ignore the air resistance, so horizontal velocity is not changing. Then what will happen? The acceleration is constant. That is, the acceleration is equals to 9.8 meters per second square. So the vertical velocity decrease when the projectile moves against the gravity or upward, and it will increase and it will be zero at the maximum height. You just have to explain the motion here. And a very important point, whenever you relate a projectile motion, the important statement you will always mention that the horizontal and the vertical velocities are independent of each other. Horizontal and vertical velocities does not depend on each other, so that's always the case. Yeah, acceleration, it should be negative 9.8. I just mentioned the point. Acceleration is negative 9.8, which is also representing a deceleration. So for a project, this is always a structure answer. Whenever a question is there, explain the projectile motion, you should always write this structured answer. Now in part C, when a toy balloon is hit quickly up at an angle, it appeared to follow the path similar to that in the 15th century. Like the path in the 15th century, this was a path given in the 15th century. And you have observed, like example, if you hit a balloon, what is the trajectory the balloon will follow? When you hit a balloon, it will go up and then it will come down. So why the balloon follows the same trajectory as it was described in the 15th century? So balloon is an ideal case. So what is the reason why the balloon follow the same trajectory? So what is the reason why the balloon follows the same trajectory which was described in the 15th century? So in case of a balloon, air resistance is not negligible. Like the projectile motion, we always assume that the air resistance is negligible. So this will be the trajectory or the path it will follow. So in case of a balloon, air resistance is acting. As a result, the horizontal velocity will decrease. When the horizontal velocity will decrease, what will happen? At certain point, the horizontal velocity will be zero. So the balloon will move downward because of gravity. So what actually happened here? What actually happened? Like we launch a projectile. Say we launch a projectile, it is having a horizontal velocity and the vertical velocity. Okay. The vertical velocity is decreasing and horizontal velocity is also decreasing. at a certain position, the horizontal velocity will be 0 and the vertical velocity is also 0. So when both velocities are 0, what is the force acting? The gravitational force is acting. And because of this gravitational force, what will happen? The trajectory which it will follow, it reaches a certain point, and then because there is no horizontal velocity, so it will accelerate downward because of the gravitational force. They did not mention the air resistance is acting on the balloon, but this is the ideal case. So for the ideal case, you have to take air resistance in consideration. This is not the ideal case. This is a practical case. So when there's a practical case, you have to consider the air resistance. If it was an ideal case, then we do ignore the air resistance. So practically what happened, the balloon is having the horizontal and the vertical both velocities. But when it is going up, the vertical velocity is decreasing and horizontal is also decreasing. And at the maximum height, the horizontal is 0, the vertical is also 0. So when both components are 0, the force of the gravity, or because of its weight, it will move downward or accelerate due to gravity. Is it clear? Part C, anyone having a doubt or a question?
No, sir.
Is it clear to everyone? The next question, the photograph shows a model of a war wolf, a siege engine used in the 13th century. It was used to attack a castle by firing a missile from the sling. So there's a question why we did not consider the air resistance in this part, because this is an explanation of a projectile. So when we explain the projectile, we ignore the air resistance. We don't consider air resistance. But what happened when a projectile is launched and there's an air resistance, then this will be the trajectory it will follow. So ideal cases, we ignore air resistance. Practically, yes, there is always a air resistance act. So in question 2, to operate the model, a coin is placed in a basket. So how this model works? So the coins are placed in this basket. So the coins are placed in this basket, and a small projectile is placed at a sling. As you can see here, small projectile is placed on this sling. When a basket is released, the basket will move downward. It fall quickly and thus swing in a lever arm, like this lever arm swings. So this lever arm will swing and shooting the projectile from the sling. On one occasion, the mass of the coin placed in the basket was 0.41 kg. The basket fell through a vertical distance of 7 centimeter. The mass placed was 0.41 kilogram. Calculate the maximum amount of energy available to launch this projectile. So actually what is happening, that when this basket is going down, the lever will move upward and it will launch this projectile. So the energy, the gravitational potential energy, or the change in the gravitational potential energy is actually the energy available to launch this projectile. So calculate the maximum amount of energy available. So here we have to calculate the gravitational potential energy. You have learned the formula for gravitational potential energy in IGCSE. So it's the mass, which is 0.41, multiplied by gravity 9.81, multiplied by height, that is given in centimeters. So we have to convert into meter. So 0.07. So this is the energy available for, which is 0.281 joules of energy is available to launch this projectile. Is it clear, this question? So when the basket will move downward, the lever of the projectile, lever of this war wolf will move and it will launch a projectile. Next is the energy conversion calculation predict that the projectile speed should be 16. The projectile is observed to fly out a sling at an angle of 40 to the horizontal. Resolve the velocity into horizontal and vertical components. So the projectile, they mention it is moving at a speed of 16 meters per second at an angle of 40 to the horizontal. So this will have the two component. One of the component is horizontal and another component will be the vertical. What will be the horizontal component here? Sine or cosine? The horizontal component.
Cosine.
Cosine, because one which is with an angle, it's cosine. So this will be 16 cosine 40. Opposite to the angle will be 16 sine
Sine.
40. So we just have to calculate the horizontal and the vertical components here. So simplify, the horizontal component of the velocity will be equal to 16 cosine 40 and write the answer here. And the vertical component of the velocity will be 16 sine 40. Write the answer here. Okay. The next is, now this is like the practical question. The predicted range is 27 meters. Like when we launch this projectile at a speed of 16 meters per second at an angle of 40, what is the predicted range? Means how much distance it should cover according to the values which we calculated. It is predicted that it should travel 27 meters. But practically, it only travel 8 meters. Air resistance and the friction in the machines are the possible reasons. So you cannot mention because of air resistance, it has a shorter range, or you cannot mention the friction in the machine is responsible for the shorter range compared to the, without further calculation. You don't have to calculate anything. Explain another reason why the projectile does not go as far as predicted. Yes. What might be the reason? You cannot mention friction or air resistance. Other than that, crosswind is also one of the student answered crosswind. Actually, crosswind will be count as a air resistance. That is one thing. Angle, as some student mentioned, the angle of the launch might be different. That's good because we predicted that it should go at an angle of 40, like it will be angle 40 from the horizontal, but angle might be different. If the angle is different, the range will also be different. Range is maximum when the angle is 45. We have a maximum range when the angle is 45. Any other angle above or below 45, the range will be minimum. That is one reason of that. What is another reason? So one of the reason is the angle. The second reason, speed may not be 16, the height from which it is thrown. Yeah, that is good. Many reasons are there about. One is speed might not be 16, or what might happen, some of the energy, like because we assume when this is going down, it will have a gravitational and this has a kinetic. But what might happen, the projectile may not be launched exactly where at this point. Maybe it is launched at this point. Because if it is launched at different positions, the launching position of the projectile, that will also affect. As it will move upward, maybe it is released from here, or maybe it is released from here. So it will have a different trajectories or the path. So the range will be different. So many possible answers are there for this one. Or some, not all of the energy is transferred to the projectile. Some of the energy is absorbed by these strings. The launching angle, as you mentioned, the launching angles are different. So if I launch a projectile from this position, I launch a projectile horizontally, or I launch a projectile at this position, they will have different ranges. Another point that these strings may absorb some energy. It's not about friction because elastic strain energy absorbed in the string that will also leads to a lower value of the range. Is it clear, this one? The next question, when a soft mint sweets are dropped into a bottle containing a fizzy drink, there's a sudden release of a gas which forces a long stream of a fluid out from the bottle. A student decides to calculate the amount of the kinetic energy transferred to the fluid in this process. In one experiment, student placed the bottle at an angle of 50 to the horizontal and he adds the sweets and measure the maximum horizontal distance traveled by the fluid. The student then calculate the fluid that is left the bottle at a speed of 7.5 meters per second. Show that the initial horizontal component of the velocity is about 5. So student then calculate that the fluid left the bottle at a speed of 7.5. So example, the fluid left at an angle of 7.5 meters per second is the speed and the angle is 50 degrees. We need the horizontal, initial horizontal. So how to work out the initial horizontal? If we need the initial horizontal, should I use sine or cosine?
7.5 times cosine 50.
So 7.5 times cosine 50. So we'll get the initial horizontal one. The next word show that the initial vertical is about 6. So how to work out the vertical? So that will be 7.5 sine 50. So horizontal component, if the angle with horizontal is written, if it's cosine, if angle with vertical is given, it will be sine. Use these values to calculate the maximum horizontal distance traveled by the projectile. So we have like horizontal example, it's 5 and the vertical is 6. So we are launching a projectile which has a speed of 7.5 meters per second. And it has two components, the horizontal and the vertical. The horizontal component is 5 meters per second and the vertical component is 6 meters per second. So vertical component is 6 meters per second. The question is maximum horizontal distance, or we need the range of this projectile. So I give you an idea whenever you're solving a question related to the projectile, even though they ask or they don't ask, always find the time to reach the maximum height. Always. So always find the time to reach the maximum height, even it's a part of the question, or if it's not a part of a question, you will always try to find that. Okay. So because to get the range, if you want the range of this projectile, range is a horizontal speed multiplied by time. That will be the range. We have the horizontal speed, but we don't know the time. So first what we do, we work out the time to reach the maximum height. That is one way of doing it. Another way, you can also find the total time of the flight. How you can find the total time of the flight? So you can use the equation of the motion S is equals to ut plus half at square. There is a direct formula. You can use that direct formula, or you can also use this formula. S is equals to ut plus half at square. I can use this if I consider as a complete motion, I can use this. Or there's also another way to solve this question, that I can find the time to reach the maximum height. At the maximum height, the vertical velocity is 0. And we know it will have a deceleration of 9.8. So if I use the first equation of the motion, which is v is equals to u plus at. So final speed, vertical speed is 0. Initial vertical speed is 6. The acceleration is due to gravity negative and time is t. If I need t, so this will be negative 6 is equals to minus 9.8 t. Negative sign will cancel with negative sign. So it will be 6 divided by 9.8. What's the time to reach the maximum height? 6 divided by 9.8. 0.612. So 0.612 is the time to reach the maximum height. So what is the total time of the flight? The total time of the flight will be twice. So you will have the total time of the flight and you have the horizontal speed, which is 5. The total time of the flight will be double, 1.224. So the total time of the flight will be 1.224. So you multiply, you will get the range of this projectile. That is one way of doing the question. What is the second way of solving the same question? Like here, first we got the time to reach the maximum height, and then we double that. You can, so range is 6.12 meters. Okay. So the range is 6.12 meters. This is one way of doing the question. The second way, you consider this as a whole as one motion. So when you consider this as one motion, vertical velocity is there 6 meters per second, and the horizontal velocity was 5 meters per second. Look, we are considering a vertical motion. It's going up and coming down, and we use the equation of the motion. So S is equals to ut plus half at square. What about the vertical displacement? If it landed on the same level, the vertical displacement will be 0. What about the u here? As I mentioned, whenever we use the equation of the motion, we never substitute the horizontal component, because the horizontal component, it is for only constant speed. As equation of the motion, object is accelerating. So we use the equation of motion in that case. So in this case, the initial velocity I will consider as a vertical velocity. This t, I don't know, plus half. And whenever a complete motion is there, expression is always like negative. So we put negative minus 9.8 t square. Now we simplify this. So this will be 0 is equals to 6t minus 1 by, this we simplify. So this will become minus 4.9, because 9.8 divided by 2. So this will be 4.9 t square. 4.9 move other side, so 4.9 t square is equals to 6t. Then the square will cancel with the t. So the t will be 6 divided by 4.9. So 6 divided by 4.9, again you should get the same answer for the time, which was 1.224 seconds. So, and we have now, this time is the total time of the flight. So we have the total time of the flight and we have the horizontal speed. So when we multiply them, we'll get the range of this projectile. So range is the horizontal speed multiplied by time. Whenever vertical motion, you consider, you always use the equations of the motion, as we consider the acceleration is due to gravity, which is a constant. Is it clear, this one? Anyone having a doubt or a
Yes, sir.
question?
No.
So either you consider the full motion. The next is to calculate the total amount of energy transferred to the fluid. The mass of the bottle content and the fluid before the experiment was 2.24, and the total mass of a content after the experiment is 0.79 kg. Amount of energy transferred to the fluid. So how much? Because this is it's beginning of the experiment. This mass was there. After the not all of the liquid escaped the bottle. So how much liquid? It was 2.24 kilogram in the beginning and 0.79 kilogram at the end. So how much liquid like move out from this bottle? So difference will be there. So 2.24 minus 0.79. What's the answer for the mass which left? So 1.45 kg. And at what speed? Because they already mentioned it leaves the bottle at a speed of 7.5 meters per second. So we have the speed here, because when kinetic energy, we just need a magnitude to work out the kinetic energy, or EK, which is a formula half mv square. Here V is not the velocity, V is the speed. So we just need the magnitude of the speed. And what is the magnitude of the speed? That was 7.5. So we'll just half the mass is 1.45 and the speed at which it will come out, that was 7.5 square. So half 1.45 into 7.5 square, that will give us the kinetic energy of the fluid. Which is 40.78, or I can say 40.8 joules. So always write your answer in three significant figures. The next is give a reason why your value of the kinetic energy might be higher than the true value. Like we calculated the kinetic energy to be 40.8 joules, but in reality, it might be less, like higher than the true value. Like the true value that might be less than what we calculated. So that is one reason, like students mentioned air resistance, that's fine. One is the air resistance, or even the mass which is transferred. So that is correct. The air resistance, one of the reason that because the air resistance is there, so true value might be lower than what we calculated. The second is give a reason why it might be higher than the true value. Like why the true value, why your value of a kinetic energy might be lower than the true value. Like we calculated 40.8, but in practical it might be more. What might be the reason for that? Because the kinetic energy depends on the mass and speed. Half mv square. So why the value of the energy might be lower than the true values? What might be the reason for that? The reason is, yeah, the speed at which the particles are coming out, or even the mass of the liquid which is because what might happen, some of the liquid when it's splashed out it might return back, so the decrease in the mass will be smaller. So give a reason why your value of a kinetic energy might be higher